Hi everyone, today we are going to discuss solving second-degree trig equations by factoring. A second-degree trig equation is simply something that has a squared in it. So this example right here, example number 1, is a second-degree trig equation. And the way that we're going to solve these is that we're going to first substitute x for the given trig function. And if you look at example number 1, what is the given trig function? They give you sine. So we're going to start off by letting x, so we can write this over here, let x equal sine of theta. And if we look at the first part, it says sine of theta squared. So couldn't that just mean x squared? Minus sine of theta, which we said was x, equals 0. It's already equal to 0, so we've satisfied step 2. And now we have to factor it. So what is the first type of factoring that we look for? We look for GCF. We're going to take out an x, and I'm followed with x minus 1 equals 0. And then we're going to do our t-chart and set each piece equal to 0. So x equals 0 and x minus 1 equals 0. And over here, how do I get x by itself? Simply add 1 to both sides. So this would be x equals 1. Now that I have my two solutions, I'm going to do step 3, which says substitute the trig function back in for x. And I'm going to do this to the right just so that I have some space. So where it said x equals 0, I'm going to change that to say sine of theta equals 0. And where it says x equals 1, I'm going to change that to say sine of theta equals 1. Now, what did I say when we did first degree trig equations? If you get 0 or 1, you need to think the unit circle. So maybe it would be best if we drew one. And we'll call this point 1, 0, this point 0, negative 1, negative 1, 0, and 0, 1. And what was sine again? The x value or the y value? All right, you should be saying y value. So where is the y value or sine equal to 0? Here and here. What are those values? Those values are theta would equal 0, theta would equal 360, 0 and 360 come from here, this side. What would this side be? 180. So that would be my third one. Theta equals 180. Okay, now if we look back over here, it says sine of theta equals 1. So where's the y value equal to 1? Right up here. What's that? 90 degrees. So theta equals 90. So technically, there are 4 answers to this problem. 1, 2, 3, and 4. But we have to be careful about the interval that they gave you. They gave us this interval from 0 to 360, but you see how there's no lines underneath these inequality signs? That means I'm not including 0 and I'm not including 360. Doesn't mean that they're not answers, they're just saying that in this interval, I don't want them. So we actually have to reject this one and this one. So technically, with the given interval, my answers are 180 and 90. Okay, next example. Example 2. First thing that we want to do is substitute for the given trig value. And the trig function that we have is tangent. So we're going to let x equal tangent of theta. And let's write that down. And then we could substitute back in. So 4x squared equals 1. And now the second step says that it needs to be equal to 0 in order for us to factor it. So we need to move this 1 to this side. So we would simply subtract it. So what would it be? It would be 4x squared minus 1 equals 0. And now let's factor. Is there a GCF that I can pull out besides 1? No. How about dots? Is it a difference of 2 perfect squares? Yep. So this would be 2x plus 1. 2x minus 1 equals 0. Now we're ready for our t-chart. We're going to set each piece equal to 0. 2x plus 1 equals 0. 2x minus 1 equals 0. So now I'm just going to start with this equation, and let's minus 1 on both sides. 2x equals negative 1, divide by 2. X equals negative 1/2. Okay, how about the other side? Add 1 to both sides. 2x equals 1. Divide by 2. X equals 1/2. So now that I have my two solutions, I'm going to go back and substitute what I let x equal in the first place. What did I let it equal? Tangent of theta. So we're going to have two different parts over here. Tangent of theta equals negative 1/2. And we're going to have that tangent of theta equals positive 1/2. Okay, how do I find the theta? Remember, to find theta, we have to take inverse of tan. Are we going to put the negative in though? No, the negative just tells us what? Tells us placement, so where we are. So if we want to draw my A, S, T, C, where is tangent negative? Here and here. So my two answers need to be in quadrant 2 and quadrant 4. So let's go ahead and find theta. So theta would be found by taking tan negative 1 of positive 1/2. So go ahead, pause the video, grab your calculator. Once you have your calculator, we're going to hit second tan 1/2, close parentheses. And we get about 26.5. And the directions above said round to the nearest whole number. So we'll make this about 27 degrees. Now that theta being 27 degrees is your reference angle. So my reference angle is in quadrant 1. I don't want that, but I need to use it to help me find the angle in quadrant 2 and the angle in quadrant 4. Remember, reference angle of 27 would be here. How do I find this angle? So for quadrant 2, we're going to do 180 minus 27. So go ahead, put 180 minus 27 in the calculator, and you should get 153. That is your angle in quadrant 2. How would I find my angle in quadrant 4? Again, remember my reference angle would be here, 27. How do I find the whole thing? Do 360 minus 27. Let's put that into the calculator, and we get 333. These two are my final answers. And let's double check that interval. Are they between 0 and 360? Yup. Why am I not including this one more time? Because that's an angle in quadrant 1, and tangent is negative here and here. Okay, we're unfortunately not done yet because we still have to do this guy. So tangent of theta is equal to positive 1/2. So what quadrants are we going to be in? A, S, T, C will be quadrant 1 and quadrant 3. Okay, well, we know to find theta, isn't it the same exact way as we found it over here? We're going to just, if you want to write it again, you can. So theta is equal to tan negative 1 of 1/2, and you get 27. And this time, the 27 counts because that's an angle we want in this quadrant. How do I find in quadrant 3? Remember, if this is my angle that terminates, this is 27. I'm going to find this whole thing. I'm going to take 180, which is all this, and add 27. So for quadrant 3, it would be 180 plus 27. So go ahead and put that in the calculator, and you should get 207. So this answer is for quadrant 3. This answer is for quadrant 1. So there are 4 answers for this problem. I know it's a lot of work, but it's just like first degree. From here on is all about first degree trig equations. The only thing I've added was a little bit of factoring. Okay, let's try example 3. Okay, the trig function that's given here is secant, so we're going to do the same thing. We're going to let x equal secant of theta. So let's go ahead and write that down. Let x equal secant theta. So x squared minus 3x equals 28. It's not set equal to 0, but how do I get this 28 to this side? Simply subtract. Now factor. We don't need to use earmuff for this, great, because there's a coefficient of 1 here. So what two numbers add to negative 3 that multiply to negative 28? Take a minute, pause the video if you want. These should be your factors. Again, t-chart. So x minus 7 is either equal to 0 or x plus 4 is equal to 0. Add 7 minus 4 and x is equal to negative 4. So again, what did we let x equal? Secant. So we can say secant of theta equals 7, or secant of theta equals negative 4. Now to find theta, we would do the inverse of secant. So second secant, but wait a minute, there is no secant button, so we need to write this in terms of cos. So wouldn't you agree that cosine of theta would be 1 over 7, the reciprocal, and that cosine of theta here would be equal to negative 1 over 4? Okay, so now let's rewrite them up top just so that we have some space. Okay, so cosine of theta, let's look at the first one. Cosine of theta is equal to a positive 1 over 7. So let's first figure out where we are. So A, S, T, C. Positive here, positive here. Okay, how do I find theta? So theta is found by taking second cos of 1 over 7. So theta inverse cos, or cos negative 1, of 1 over 7. So let's go ahead and put that into the calculator. Second cos, 1 over 7, close parentheses. So you get about 82 degrees. Fine. Theta is 82. Does that work for our quadrant that we're supposed to be in? Yeah, we're in quadrant 1 and quadrant 4. So we have the angle in quadrant 1, so we can go ahead and box that. That's an answer. Now how are we going to use that 82 to find an angle in quadrant 4? Well, remember, reference angle 82. So to find the angle in quadrant 4, we're just going to do 360 minus 82. So let's go ahead and put that in the calculator, and you should get 278. That should be your other answer for theta. Okay, now let's jump over to the second piece. The second piece says cos of theta equals negative 1/4. So again, the negative just tells us placement, just tells us where we are. So cosine is negative here and here. Well, we need to find that reference angle first. So to find theta, we're going to do second cos, so cos negative 1, of positive 1/4. Don't put that negative in the calculator. So put in the calculator second cos, 1 over 4. And you're going to get about 76. So theta is 76 degrees. Now this 76 is the reference angle, the angle in quadrant 1. But I need the angle in quadrant 2 and quadrant 3. So for quadrant 2, we would do 180 minus 76. So let's go ahead and do that. You get about 104. Now let's find the angle in quadrant 3. How do I do that? 180 plus 76. So let's go ahead and put that into the calculator. And you should get about 256. So let's box all those. So technically I have 4 answers. 1, 2, 3, 4. We just have to check that they're within the interval. Are they? Well, is it between 0 and 2 pi? 2 pi is 360 degrees. Yep. Now technically, since the interval's in radian, the answer should be in radian, but there's too much written on the paper right now, so we'll discuss that tomorrow. I'd like you to try example number 4 for homework, but I'd like to set you up for it first. So let's let x equal cosine of theta, and what would this be? 2x squared plus x minus 1 equals 0. Now, this is a trinomial because it has 3 terms. There's no GCF other than 1, so I can't use GCF, can't use dots. Now, I would have to use earmuff because the coefficient in front of the x squared is bigger than 1. So, just as a refresher, you multiply the first and the last, and you get negative 2x squared. And you want to find the factors that multiply to negative 2x squared that add to a positive 1. If you have trouble with this, we'll definitely go over it tomorrow, but I want to see if you can do this from start to finish. Okay, bye.